So testing, follow the software testing module. You have following things: development testing, test driven development, release testing, and user testing. So let's start with first thing. What do I mean by testing? Testing is intended to show that the program does what it is intended to do and discover any defects before it is put to use. So testing is a way of checking whether what and all functionality is required by the user, it is giving that, or it does what is intended. And while doing whatever functionality is required, it should also discover some defects. Okay, if there are any defects in whatever is functionality that is being developed, it will discover or find out any faults within your system. And whenever you're testing the software, you test it with artificial data. Naturally, you don't enter real time data, right? First time when you're testing, you test it with some artificial data, or we call it as testing data. Okay, you can check a so once we are testing, we can see whether there are any errors, or we can also check whether certain functionality is being properly working or not. Testing has two things. One is verification and the other is validation. What do you mean by verification and what do you mean by validation? Yes, sir. What do you mean by validation and what do you mean by verification? Yeah, can someone answer? There are two things in testing. One is verification and the other is validation. Checking and approval. Okay. Now, suppose I say I'm verifying the product. What does it mean? I will only answer so that you don't get confused. So, verification means checking whether the software meets its functional and non functional requirements. See, I have said I am developing a software product and I want feature 1, 2, and 3. Did you understand? Please imagine a scenario. I am a customer, you are a developer. Fine. I am the customer, you are a developer. I'm asking you for some software product. And in that software product, I am asking three features to be developed. Feature 1, 2, and 3. After a week or after a month, after the time elapsation, you come up with once you're done with the development, you give me the product and you say you can verify now. What does it mean? It means that I will check what and all features I would expected from that product is all been given by you. So verification means checking the functionality and non-functional requirements of a particular software product. Are you clear now? Whatever is expected of that system, is it delivering it? That is what means verification. The next what you have is, ma'am, then what is validation? Validation is more general, or it means that are they building the, I mean, whether whatever functionalities you have asked to develop, whether it is proper. Those features, what you have developed, whether it is working properly, I am going to check with different data. Like, let's say feature 1 does so and so. I say feature 1 should do mathematical operations. Now, if I see there are functionalities which will perform that operation, then your software is verified. Now, later I will validate it. Validate it is when I say mathematical operations, I will give different types of input and check whether it is working properly. Yes, sir. So, this is what we mean by verification and validation. Verification means are we building the product right? And in validation, are the building the right product? That is what a minor difference. Okay. Did you understand, guys? What is verification and what is validation? So, verifying is nothing but checking functional and non functional requirements. Validation means checking or more general process of testing whether it is working fine or not. So, program testing goals. What is the goal of testing? To demonstrate to the developer and the customer that the software meets its requirement. One of the most important requirement for testing is it will check whether whatever requirements was agreed between the developer and the customer has been met. So, if your software product is a custom software or a generic software, can you do you know what do you mean by custom software and generic software? Custom software is one which is developed based on the requirements for a customer. Generic software, you look into the market, get to know the latest requirements, and develop a product. That is generic software. So, if it is a custom software which you have developed, you test that software based on the requirements which is given by the customer. If it is a generic software, you test based on the features which you had developed in the or which you had given in the product release. So, the first goal of program testing is to check whether the demands of the customer or the requirements of the customer have been met. It is also used for checking whether the software is when the software behaves uh, what can I say incorrectly or undesirably, or when does problems happen, on what situation the system fails, and what are the functionalities which are not handled by the system. All that can be observed by testing. Like if the system crashes, when does it crash? Now, for what interaction? Suppose you give some incorrect input. So, what will happen during those times? If the computation is not correct, what will happen? Will it alter some other system? One thing is data corruption. Suppose if your thing you expect some functionality, it is working or you have tested it, it is working very fine. But what will happen if it is corrupting some other data in some other table? It might happen, right? So you are going to test that also. How does the system, like whether it will cause any problem to the system and its environment? Yes. So these are the two goals of program testing. So the first goal, that is what I said, validation testing, as well as it can be what verification also. The second goal is defect testing. It will see whether there is any defects in your system. So the thing where you check whether the functionality has been working properly or not, either both of functional and non-functional requirement will lead to verification and validation testing. The second will lead to defect testing, which will expose any defects in the system. Fine. So validation testing will check whether the developer and the system customer what it needs. Successful shows the show that the system operates as intended. Defect, what happens when there are faults or defects in the system, and how does the system behave in such scenarios when it is presented with I can say incorrect data or invalid data. Fine. So that is known as defect testing. Fine. Then you have something known as input output model of program testing. Let's say this is my system. This system is nothing but the software that is being developed. So this corresponds to this system corresponds to the software being developed. This software takes some input test data and produces the test results. Okay. Are you able to get it? So this system represents the software being developed, the middle one. Whatever I call it as system, it is the software that is being developed. So before developing this product software, what are the different phases that will be there? So this is the system which is being developed after requirements, design, implementation, everything. Once the system has been developed, I will give input test data. That is, I will give input to my system, and based on the input given, I will get a result. That is the test results. Agreed? Now, let's take if there are some IE. So, till here, this points, did all of you get it? This system represents the in between the middle system here. This represents the software being developed after all the phases of software development. Okay, fine. Once the system or software is being developed, to this I will give test data, and to that test data I will get an output test result. Agreed? Fine. So I will check whether for the given input I am getting the right output. Then I will check, I'll give some input IE represents an input which contains error. Okay, this E here is nothing but error. So this is error in input. Did you get it? IE. So if you give an input causing anomaly behaviors or which will cause some anomalies, then the output will reveal the presence of defects. OE represents the defects in the output. So when you give some error input, you should not get the proper output, right? You should get a something output which relieve the presence of whatever defect it is. So this is what input output model of program testing is. If you give the proper test data, you will get the proper output results. If you give some error, it should say what error was there. It should handle the error in your system, should handle the error in the input. Did you understand? Guys, can you go through it? If you have, I'll give you 2 minutes. Just go through it once. Shall I continue, guys? So, at the end, we have verification to see whether the software conforms to its specification. Validation is nothing but the software should do what the user really requires. So checking whether it meets its specification is known as verification. And validation is checking whether the user really what should what the software should do based on the user requirements. So verification says, are we building the product right? Whereas validation says, are we building the right product? Okay. So verification is at a very higher level to check what the product what you're developing is correct or not. Once you come up with the verification the software is right, you are checking what is built is correct or not. That is validation. So that is what we say, verification and validation is called as V and V. So the way aim of this verification and validation is to establish the confidence that the system is fit for purpose. So whatever software which I am developing should satisfy both the constraints V and V. So it should be verifiable and it should be validated. Okay. So whatever system or software you have developed, it should be verified as well as it should be validated. So depending upon the system's purpose, user expectations and marketing environment. So there are three things which we see in V and V model. One is the software purpose. See, what actually happens is whenever you're testing the product, it depends upon the software purpose of the product which you're developing. Suppose if I'm developing a mission critical processor, that is what we say. Suppose if you are developing a mission critical processor, then we are, it is more important that the software is very reliable. like a safety critical system in case of fire alarms or something like that. Developing a software for such kind of mission critical applications, then your software should be reliable. But if you're developing a software for a web-based application or something like that, then uh, then it is fine. Fine in the sense, even if there are some problems, or if the system is not working properly for certain cases, then it is acceptable. Agreed? See, if you're developing a software for a mission critical application, then your software should be reliable. Reliable in the sense it should always work correctly for all cases. Similarly, or if you're developing a software for a web-based application, then even if the software fails, even if it is not reliable, then it is fine. So always this verification and validation is dependent upon the software what you are developing. Fine. Next thing is user expectations. Now, most of the times, whenever an end user is using a new system, there will be like they are adjusted to the fact that it may have errors. So they have lower expectations of certain kinds of software. Let's say, for example, you are downloading a new game in the net. Do you think it will be working all the time or you will use it for a long time? There may be certain issues like memory consumption or it is not up to the mark or something like that, right? So always the first time when the product comes into picture, there are always low expectations about certain kinds of software. Next is marketing environment. See, whenever you're developing a product, you want to bring that product to the market at the earliest. Even though you know that it is not up to the mark or it may have some errors, what you do is you will want to bring that to the market. Agreed? Reason being is there may be the other software products or there may be other customers or your competitors who are trying to bring the same type of product. So in order to avoid that, what you try to do is you will try to bring your own product first so that it will be more popular or people will start using it. And in such cases, even there are slight errors or defects or certain features are not developed, it is acceptable. Most of the reasons why initial product versions or initial version products will have so many errors is because of this. They will have tight deadlines. They want the customers, initial customers, or they are targeting certain customers. So even when there are errors, they will try to bring that into market. So verification always depends upon three things: purpose, expectation, and environment. So how well you want to verify or how well you will validate a system will depends upon these three. If you are developing a web-based project, you will not test it to the core, and you will know that there will be certain errors, and the customer also will expect that there will be certain errors, and just you will go ahead and you will come up with a or you will release the product with not that much testing. But if it is a product which is developed for mission critical applications, then your validation and verification and validation will be different for that kind of software. So your V and V will depend upon three things. One is the purpose, the other is the expectations, and the other is the marketing environment. Any doubts in this? All of you are sleeping? Hmm? Guys? No. Only Kavya and Lavanya, no one else. Okay. There are two things while considering verification and validation. One is inspection and the other is testing. What do I mean by software inspection? And what do I mean by testing? Testing, I will say, it is nothing but once this product is developed, you check for the product for any errors in the system. Okay. Then what is inspection, ma'am? See, inspection means going through the source code of a system or any readable presentation. Here, you're not running the system. That is why we call it as a static verification. What is static means you're not running the system before the code is put into use. You do this inspection. It is called as static. Reason being is you're not only apply it to the source code, you apply it to the requirements documents or design models or design patterns or something like that. So inspection is something is like going through the source code. Going through the source code means yes, you write a source code or a logic or a flow chart, right? What do? You check, verify it manually, right? Before executing the program, what do? You check manually if there are chances of any errors, like maybe semicolon missing, or the looping is starting from 0 instead of 1, or the termination condition is not proper, or the variable is already being used. All these kinds of errors you can make out by seeing the code, right? What you have typed, you need not have to run it. Did you get it? So that kind of checking within the source code or within the documents, document in the sense I already have a software requirements document. There it is expected that it should deliver something, but that is not covered in the requirements document. You find it out and you fix it, or you change it. Same in design. In design, let's say it is an object oriented design and I have come up with an object diagram. Now, some of the attributes are missing there. I want to add that attribute. I'm checking whether the attribute covers all the data. So, all those kinds of testing or checking is known as inspection. Because it does not operate at runtime or when the program is executing, we call it as a static verification. So, software inspection can happen to either a source code, requirements document, or design documents. Whereas testing is a dynamic verification wherein you execute the system, give the test data, and you get the behavior or the output. Did you understand? What do you mean by inspection and what is testing? Inspection is static, whereas testing is dynamic. So, inspection can apply to what? To the requirement specification, to the system's software architecture, UML design models, database schemas, all this can be inspected. Even the program code, what you have written, can also be inspected. Whereas testing can be done only to the program and only to the system prototype. Now I want everyone to concentrate. This picture tells all the explanation needed. See, inspection can be applied to all the things: requirements, architecture, design models, database schemas, as well as programs. Whereas testing can be applied only to the program or to the prototype. Now tell me, what do you think is the advantage of inspection and testing? By seeing this, you should be able to tell which is more. Okay, fine. I will reframe my question. Which do you think is more appropriate? Inspection, excuse me, or testing? Which is better? Which is good? Something like that? Yes. Go through this diagram, understand what I said, and tell me which is better. Is it inspection or testing? Okay, come on, students. Now you have to tell me, if you have to prefer, which one will you prefer? Inspection or testing? Okay. Ankita's answer is both are good and have their own importance. Yeah, fine. Any others have any other opinion? Manik says inspection is more efficient. Okay. Yes. Anyone? Others? Inspection is more preferable. Okay. More routes for inspection. Fine. Anyone else? Fine. What would I like to say is, if my answer would be what Ankita, I would agree with her. Both are good and have their own importance. See, yes, inspection has one advantage. Yes. See, The advantage of inspection is it can start from the phase right from requirement collection. Pros and cons I'm trying to tell. So when I take up inspection, I can start it right when the product started development during day one, and continue till the program has been developed. And also, the advantage of inspection is if I identify any problem earlier, then it will save me the cost. How can you say that, ma'am? Let's say, for example, there was some problem within the software architecture here. Okay, one error, single error. Now, if there was no inspection, what it happens is the same error will get propagated to design, and the same will get propagated to program. And if I want to fix this error, by only testing is employed, if only testing is employed, what happens is testing is applied during this program here. I will fix the error here, then I have to fix the error within my design, then I have to fix my error in software architecture. Did you understand? Imagine how many things I have to do. What is the cost incurred? Not in one place, but in three places. If I had inspection in one, had done inspection, and if I was proper, I would have identified the error at the first stage. So, one second, guys. So, if it is testing, the error will get propagated here. If I am using inspection, who was okay. If it is inspection, there will be one error which will be identified during this phase itself, and it can be fixed. It will not get propagated to the design or to the program. So this is the advantage of having an inspection. Okay, ma'am. I will, because of this, I will take only inspection. Like, so now you will say, Manik and Lavanya will say yes. That is why we said inspection is correct. Fine. Let me take up inspection and this testing is not there. Yeah. Then what happens? Yes, I fixed here one error. But while I'm doing the program or something, I've developed with the program, and if I don't do testing, there may be some cases dynamically when you're running the program, there may be some mistakes or there may be some errors in the program. So when we have such kind of things, this inspection will not be able to find those errors within our program. So our software should have both inspections as well as testing, or should incorporate both inspection as well as testing. And that is the reason why most of the companies employ both the techniques for fixing any errors. Got it? Do you know what happens, Lavanya, is no matter, see, you can read and tell no matter how many things, but in real time situation, how the system works, you will never know. Inspection is always static. Yes, I might say within my software specification that the calculator program will work only for valid inputs. Now, while inspection, it will say yes, it is correct. But during my program error while running, it may not take for some not may not work for some cases. So testing is the only way to find out all those dynamically, whatever I can say, available, or dynamically whatever errors can be there within the program. So only inspections will never be. See, one thing I can say. No, you have written a C program, Lavanya, and you check it 10 times, 20 times. So after checking the 20th time without compiling it, can you say it is perfectly correct that program? Right? There may be some error you might not have observed it, right? That is what with this testing. Inspection you do 20 times, 200 times, but until you test it, you cannot say your system is correct, 100% correct. Fine? That is the difference between testing and inspection, like you do it in your C program. You might check your C program 10 times, 20 times, but until and unless you compile and you get no errors, you will never be knowing what is the uh, problem in your program, right? So, inspection is like checking your program, testing is like compiling your program. Fine with this? Okay, guys, shall I stop at this stage? And the students who have to prepare for the presentation today, have you prepared? Okay, let me take my attendance register. So, who is the first person? I think Rishita, right? Because Bhargav was not there and Sri Harsh was not there. Yeah, Rishita, you can start. If you want me to share any presentation, let me know.
Good afternoon, everyone. So here today I'm discussing about waterfall model. Software process model is a simplified representation of a software process. Each process model represents a process from a particular perspective and thus it provides only partial information about that process. One among the software process models is waterfall model. Here in the waterfall model we are having five different phases: requirement analysis and definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance. This is the first software development lifecycle model used widely in software engineering to ensure success of the project. So, in the approach, the whole process of software development is divided into five separate phases. Here, the output of one phase acts as the input of next phase. Because of the cascade from one phase to another, this model is known as the waterfall model. First phase is requirement analysis. Here, the requirement is gathered and documented in a requirement specification document. Whatever the user requirements or customer requirements, that will be the first documented here. They are then defined and detailed and serve as a system specification. Next phase is system design. System design helps in specifying hardware and the system requirements and also defining overall system architecture. Software design involves identifying and describing the fundamental software system, abstractions, and their relationships. After knowing about requirement analysis and system design, the next phase is implementation. In implementation, the system is developed in small programs called units. Here, we implement the program into small units. Unit testing involves verifying that each unit meets its specification. Here, each unit is tested for its functionality and is referred as unit testing. Next is integration and system testing. The individual program units are integrated and tested as a complete system to ensure that the software requirements have been met. After testing, the software system is delivered to the customer. The last phase is operation and maintenance. This is the longest life cycle phase. The system is installed and put into practical use. Maintenance involves correcting errors which are not discovered in earlier stages of the life cycle, improving the implementation of system units and enhancing the system services as new requirements are discovered. Now, let us see the advantages and disadvantages of using waterfall model. Advantages. It is simple and easy to understand and use. Also, it is easy to manage and each phase has specific delivery and review process. Phases are processed and completed one at a time. In waterfall model, requirements are well understood. The stages are clearly defined. This makes the process visible so managers can monitor progress against the development plan. Disadvantages. The major disadvantage in waterfall model is inflexible partitioning of the project into distinct stages and high amount of risk and uncertainty will be there. It is not proper for object oriented program and it is also complex. In this process, commitments must be made at an early stage, which makes it difficult to respond to changing customer requirements. Thank you.
Thanks, Parishita. I think you covered all the points from the different steps to advantages to disadvantages. Thank you, Rishita. Well done. So, next person, Rakshit.
Yes, ma'am.
Yapa.
Good afternoon, everyone. My topic is the process activities. Real software processes are interleaved sequences of technical, collaborative, and managerial activities with the overall goal of specifying, designing, implementing, and testing a software system. The four basic properties activities of are specification, design and development, validation, and evolution, which are organized differently in different development processes. For example, in waterfall model, they are organized in sequences, whereas in incremental development, they are in interleaved. So first is the software specification, the process of establishing what services are required and the constraints on the system's operation and development. Requirements engineering in requirement engineering process, feasibility study, is it technically and financially feasible to build the system? Or requirements elicitation and analysis, what do the system stakeholders require or expect from the system? Requirements
Rakshit,
yes ma'am.
Rakshit, when you say feasibility study, just
Yeah.
give a break and say what it is. Now it
Okay.
is like you're just reading, okay? So
Okay.
imagine if you're telling me what does it mean, then you have to give a pause, right? Feasibility study. It so something like that, huh?
Yeah.
Give a you. I know you've got all the material correct. Just give a pause while telling so that the others can understand. Fine.
Yeah, fine.
Okay. Yeah. Continue, sir.
Requirements elicitation and analysis. What do the system stakeholders require or expect from the system? Requirement specification is defining the requirements in detail. Requirements validation is checking the validity of the requirements. Next is the software design and implementation. It is the process of converting the system specifications into an executable system. Uh, System design, software design is the design of a software structure that realizes the specifications. Implementation is the translate this structure into an executable program. The activities of design and implementation are closely related and may be interleaved. There are four design activities that are architectural design, where you identify the overall structure of the system, the principal components and their relationships, and how they are distributed. Interface design, where you define the interfaces between system components. Next is a component design, where you take each system component and design how it will operate. Next is a database design, where you design the system that structures and how these are to be represented to the database. Next is the software validation. And this verification and validation is intended to show that the system conforms to its specification and meets the requirements of the system customer. Involves checking and review process and system testing. System testing involves executing the system with test cases that are derived from the specification to the real data to be processed by the system. Testing is most commonly used verification and validation activity. There are three stages of testing: development or component testing. Individual components are tested independently. Components may be functions or objects or coherent grouping of these entities. Next is the system testing. Testing of the system as a whole. Testing of emergent properties is particularly important. Next is the acceptance testing. Testing with customer data to check that the system meets the customer needs. Next is the software evolution. Software is inherently fixable and can change as requirements change. Though changing business circumstances, the software that supports the business must also evolve and change. Although there has been a demonstration between development and evolution, this is increasing irrelevant as fewer and fewer systems are getting completely new. So, thank you, ma'am.
Thanks, Rakshit. Rakshit, actually, you took a very big topic.
Yeah, ma'am.
And yeah, the thing is, when you have taken such a topics, you should always have a presentation or you should have a slide which will have different types. Otherwise, explaining like it was not, you tried your best, but the problem is there are so many points, it becomes confusing. Correct?
Yeah, ma'am. Just I told for 10 marks question, what are the
Yeah.
in points in?
That's the reason. Okay.
Yeah,
So next time, if anyone is taking such a big topic, actually, I should congratulate you. You had taken a very big topic, and explaining it will not be easy. So if you are taking such topics, takes put two slides. Only
yeah,
put headings there. Now, if it is software process activities, put the four activities. And within that four, what are the headings of different activities involved? Just have that, and you can go on explaining. Okay.
okay.
Yeah, but still, when I said you for you to slow down, yes, you slow down and you try to do your best. But such kinds of topics, when you take, you require an aid to support your presentation. Otherwise, it becomes difficult. Okay,
Yeah, okay.
but nice job, good job. Okay,
Thank you, ma'am.
yeah, thanks, Rakshit. Chandan, not there. Chandrakant,
Yes, ma'am.
are you ready, pa?
Yes, ma'am. I'm ready. But I've taken some images of this Bohm spiral model, ma'am. I want
Yeah.
to present it on my phone.
Yeah, you can either you send it to me, I will put, or if you want to take the presentation rights,
I
you
just
can
try
take.
to present it, ma'am.
You will say you will present it?
Yes, ma'am. I'll try it, ma'am. If it's not
Yeah.
possible, I'll see you.
Okay, pa. I have stopped presenting. You can take the control now.
So, hope my screen is visible to you all. Is it
Yes,
visible,
pa.
ma'am?
Yes, pa. Visible, visible.
So, hello everyone, this is Chandrakant, and today I'm here to speak a few words on Bohm spiral model. To begin with, let us start with software process model. So these software process models are the abstract representation of software process activities, and each model explains these process activities in their own perspective. So each and every model has its own merits and demerits too. These models can be used to explain different approaches to software development. So one of such models is Bohm spiral model. So this is the Bohm spiral model. It was proposed by Bohm in 1988. In this model, each and every process is represented in a spiral. So this becomes a major advantage to us because we need not have to backtrack the all the process activities if we want to implement any changes or modifications in the system software in the software system. So as we can make out by seeing this diagram, the first loop might be concerned with the system feasibility, the next loop with the requirements definition, the next loop with the design implementation, and so on. So the model mainly concentrates on reducing the risk factors. So basically, this spiral model is an iterative process in which we keep on repeating the process activities until we get our desired product. So let me illustrate this with an example which I have chosen. So there are four phases in this model, namely the planning, and second one is the risk analysis, third one is design, and the fourth one is evaluation. In the first phase, the system services and the constraints on the process and products are defined by the customers or by the company, and all the requirement specifications are made. In the second phase, that is the risk analysis phase, all the risks are identified and assessed, and the solutions to these risks are planned. And the next phase is design phase. This process allocates the requirements to either hardware or software systems by establishing the overall system architecture. And the next phase is evaluation. The output which we obtain from all these phases is evaluated in this phase, and the next iteration is planned, and we get the prototype 1. Similarly, this process is repeated in the same way, and we get the prototype 2 and prototype 3 and then prototype 4. The process is repeated until and unless we get the desired product. So this is an iterative process. So spiral model represents the way of developing an objective by going through all these iterative phases. It means that we go back to the beginning of the phase and we'll have something that we some outcome of that particular phase. See, consider this as an objective. This is the product which we have to consider this as an objective which we have to design. So it means that we go back to the beginning of the phase with the sum outcome of that particular iteration. See, after the iteration, we'll be getting the output so far. That is the output of first iteration, and we work on it and we plan for the enhancement. We plan for the enhancement of the outcome which we have got from the iteration, and finally, by undergoing all these phases again and again in an iterative manner, we end up getting our desired product. So this is our desired product. So this is about the working of Bohm spiral model. So let us see some of the advantages of Bohm spiral model. So first advantage is risk reduction. The extensive risk analysis which we do in this model, it reduces the chance of the project to fail. And the second one is functionality can be added in later phase. That is, functionality or any modifications can be done in later phase too because of the iterative manner of this spiral model. And the third one is software is produced early. That is, in each and every iteration, we'll be having something to show to our customers or to the company, and we can report our progress in software development, and we can also obtain their feedback, which becomes very important. So these are the advantages. And coming to the disadvantages, spiral model is a way more complex than other models like incremental model or waterfall model, and the success is highly dependent on the risk analysis. That is, if an individual fails to analyze the risk properly, this model may end up getting failed. And the last one is it becomes very costly. It becomes costly for us. This model is bit expensive because the risk analysis should be done by the people with expertise who demand for more money. So this might uh, this this might cost us more.
Chandrakant, very good. I'm really impressed. Um, I think that I should tell the others also. Ma'am, I don't have laptop. I don't have this. See, that are only reasons. He could give such a good presentation using his phone. Yes, really very good effort. Your presentation was very good. Your understanding and explaining the topic also was perfect. Very nice presentation. Thank you so much. I mean, you covered everything, why we use Bohem spiral model and an example of how it works, and also advantages and disadvantages. And the presentation what you gave, and you explained the points. Really, very good, Pa. No problem, sir. I understand. See, the others also, please present it even if it is interruptions. If someone at your home also once is there, I have no issues, sir. As long as you are not distracted and you're doing your work, it is fine. Okay? Very good, sir. Thank you so much. Please share your presentation for in case of we have to maintain a say, data about what extra has been done. So I think I will take a presentation yours and the first student who gave about I think a feasibility study or something. Both of you. Please maintain that data and you can send it across to me. And anyway, I have your recording also. Okay. Thank you so much, Chandrakant. Very good effort. Next person, Chetana.
Yes, ma'am.
Are you ready?
Yes, ma'am. Ma'am, I
Okay.
prepared a PPT on this.
Yeah, you can present. Anyway, I'm not presenting and no one else is. You can take the control.
Thank you. Ma'am, can you see the screen?
No, pa.
Mm,
Yeah, now it's giving. You're presenting. Yes, now we can see.
now, ma'am.
Yeah, I can see.
Uh, Hi, guys. I'm Chetana, and today I thought of presenting context modeling. Context modeling is used to illustrate the operational context of a system. So basically, it includes the functionality of a system and what is provided by the system environment. So let's consider a project which is divided into multiple modes. So what context model does is that it identifies the functionality of each model, which like which actually stops the duplication of modules. I mean, which prevents the duplication of modules, and it becomes easier for us to know the requirements, and which in turn saves a lot of time and resource. Here we have a simple context model of a MHC PMS. Here, here this MHC PMS system is connected to all the other system, like the appointment system, HC statistic system, management reporting system, patient record system, admission system, and prescription system.
Chetana,
So what?
first explain what MHCPMS system is and then this
Okay,
context model.
okay, ma'am.
Yeah, in
So
two lines.
this MHC PMS system is a mental health care and patient management system. uh, this is this helps to maintain a proper record of like mentally ill people. So in this application of context model, um here whatever output we get from appointment system or any other system will be the input data to the MHC PMS system. So So, considering the context model, we understand that it is not the job of MHCPS system to take the appointment system into account. So, this context model tells us what are the functions of each system in here. And if the appointment system wants to access this patient record system, it has to go through this MHC PMS system and then and then it can get access to the information whatever present in patient record system. And this is another example of context model. It is a simple context of ATM. So here, just like we saw in MHC PMS system, here we have a auto teller system which is connected to all other systems in here. It is connected to this accountable database and local branch accounting system, security system, maintenance system to support machine maintenance, usage database that monitors how the network of ATM is used, and a local branch counter system that provides services such as backup and printing. So a simple context models are used along with another models like process models. So so these models describe how the system that is being designed and developed is used in business processes. So to represent these process models, we use UML activity diagrams. What is this UML activity diagrams? Is that UML is a unified modeling language. It is a modeling language which provides way to visualize the design of a system in a form of diagram. So here we have application, one of the applications of process model, that is process model of an involuntary detention. So this process helps when the patient is not fit to socialize or in a very serious condition. Here we have rounded rectangles and also like normal rectangles. These rounded rectangles represent the activities, and this normal rectangles represent each modules. And here the solid circle indicates the starting point. So here after starting we have a activity that is confirmation of detention decision, and then this solid line represents that whatever activities are present before this line must be done immediately before going before proceeding to the next activities. So next we have inform patient of rights and record detention system. this activities will be done with the help of MHC PMS system. And then we have um, dangerous and not dangerous. This decides if, like, if the patient is in a very dangerous condition, he'll be taken to a secured place. Like, secured place means a police station or transfer to a hospital. And then if it is not that dangerous, then he'll be admitted to a hospital. And this activities will be done with the help of admission system. And then comes um, next activities. Those are like inform social care, inform next of kin, update register, and all this activities will be done by MHC PMS. And before, like, coming to this solid line, all these activities must be done. And this indicates the end of the what the process. And yeah, that is all. That's it, ma'am.
Thanks, Chetna. Why, by the end, you were very tired of explaining it? Hmm? What, pa? Actually, you did a
Yes,
good
ma'am.
job, but the thing was, you took a very big topic, and by the end of the time, by 5 minutes, you felt very tired, right? Too much of
Yes.
explanation. That's fine.
Thank you, ma'am.
Yeah, good job. Chirag, did I
Yes,
ask you
ma'am.
to do today only?
Yes, ma'am.
Okay, pa.
So I'll start. Good afternoon, everyone. This is Chirag, and I will be presenting about inheritance in OOPS or object-oriented programming. First of all, I will give what is inheritance. Definition: creating new classes from existing class so that new classes will acquire all the feature of the existing class is called inheritance. A good example of this will be parent and a child. Parent producing the children and children inheriting its behavior or the qualities from the parent. The original class is called the superclass, and the derived or extended class is called the subclass. Then we'll move to the advantages of the inheritance. We can create more useful classes needed by the application of software. This was the first advantage. Then second advantage. Next, the process of creating new classes is very easy, and since it's easy because they are built upon the already existing classes. And third advantage will be the managing the code becomes very easy since the programmer creates several classes in hierarchical manner and segregates the code into several modules. Then I will give another example which everyone will be familiar. Obviously, I've studied a seventh class, so we have studied in seventh class that in mathematics that what is a plus b whole square. A plus b whole square will be a square plus b square plus 2ab. And in eighth class, we have studied that what is a plus b whole cube. So how can we solve with a plus b whole cube? A plus b whole square into a plus b. So then we can solve it by expanding both the terms and we'll get a cube plus b cube plus 3a square plus 3ab square. I have given this example. Now consider this example. Let class 7 be a class A and class 8 be a class B. Class B will gets its behavior from class A. Means in seventh class, variables will be there like A and B are the variables will be there, and A plus B whole square will be there. Function will be there in the class A. Okay, and in class B, we remember A plus B whole cube. That is A plus B whole square into A plus B. For solving A plus B whole square, we will be using the function of that class A. So then a plus b whole cube, consider it as a function, and so we'll get the answer is a cube plus b cube plus 3a square plus 3ab square. That's all, man. It's kind of fast.
Thanks, Chirag. I'm sorry. Yeah, Chirag. Actually, this is the first time I've got an example for mathematical example someone gave for inheritance. Good.
How was it, man?
Um, Actually, there are pretty, if someone has already learned this, I mean, no inheritance, they can get it. But someone very novice, it becomes little tricky to get this example. Okay. 1 second, pa. Yeah, sorry, Chiraga. Chirag, actually, for me, it was a really good, interesting thing because I have not got this example of a mathematical example for inheritance. But someone who is very new to inheritance, maybe following that example will become a little take some time. But I think you should ask your friends about that. But really, very good, informative. Good. You could have given one more example regarding inheritance, right?
Yes,
Agree
ma'am.
or don't agree? You can
Yes, ma'am.
tell me. No, ma'am, everyone will know. You need not have to think about it.
Yes, ma'am.
But still, Chirag, good presentation. Next time, give a diagram or you take one example, something like a diagram. You could have given this mathematical example in a slide or something. Then it would have someone who is really, I don't know. From my point, I feel that maybe the others will be difficult, or who knows, all are very intelligent. They can get this example. Okay.
I gave this example just like everyone is studied seventh or eighth class, man.
Yeah, yeah. But the
So
thing
they will
is,
be knowing that what I'm saying.
yeah, but the thing is, linking this to inheritance, people who are very new to inheritance, a little bit tricky. That's it. Okay. Good, Chirag. Thank you so much. Now, did I say tell Chirantan also today? Chirantan? Not there? I think then these were the students who I've assigned, right? Anyone say I have missed? Come on, reply, guys, in case if I have missed. No. I will take it as a no. But anyway, who have given, I have marked all their names. So when will be your next class? On Wednesday. So Wednesday, someone wants to give out of turn, you want to give a presentation on Wednesday? Very enthusiastic, or shall I take from the attendance register itself? Reply? No. Fine then, let me only assign. Chitra, you're there? Pa, you'll give on Wednesday? Okay. Sankirtana? Think she is absent today also. Darshan Gowda? Darshan? Not there. Okay. Deepa NC? You will give on Wednesday, madam? Okay. Deepali? Okay, you also on Wednesday. Then Vasant Reddy? USN 40. Not there. Shri Harsha? Yeah. You also on Wednesday, sir. Fabian? Fabian, not there. He's online. Okay. Fabian on Wednesday. Suchita, you also, madam. I just want to give till 45 so that I will get a track of it. I can keep a track of it. Tushar? Okay. Gaganeshri? Gaganeshri present? No. Okay. So I'll stop at that. I would insist others to prepare 2 or 3 slides. Today, some of your friends presented, right? Even if you're using a phone, you can present. Actually, if you're using a PPT, it will be very easy for you. Fine. So try. It will not take much time. And the PPT for software engineering topics is readily available in the internet. I don't mind you downloading it and presenting it. As long as the contents are as same as your textbook topics, I won't mind. Fine. Only thing I don't want something contradictory statements for which is there in your textbook, that I don't want. Apart from that, the same topics, if you have PPTs available in the net, please use it. I have no issues with that. But I insist, please take some presentation aid. It will be easy for you, and it will be not very boring for the others also and for you also. Okay. So let me take the attendance. USN 1. Answer your attendance, guys. USN 1. USN 2.
2 present, ma'am.
Okay. 3, 4, 5. Abhishek Mishra. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. Anusha BR. Okay. Okay. 21, 22, 23, 24, 25. Bhanupriya.